Hello students, this is ASR. In previous video, we discussed the 2020 January JEE Main problems belongs to motion in a plane chapter. In this video, we discuss the 2020 January JEE Main problems belongs to Newton's laws of motion. The first problem is a mass of 10 kg is suspended by a rope of length 4 meter from the ceiling. A force F is applied horizontally at the midpoint of the rope such that the top half of the rope makes an angle of 45 degrees with vertical. Then F equals to, take G is equal to 10 meters per second square and rope to be massless. So let us consider a rope diagram here. Let this be a massless rope and a given body of mass m is equal to 10 kg is suspended to the rope. Now this rope is held at the midpoint and force is applied. The rope is pulled to a side. Here at midpoint of the rope, force is applied. Force is applied at the midpoint of the rope. It is pulled to a side such that top half of the rope makes an angle 45 degrees with the vertical. Let this be the vertical direction and this is pulled to a side until it makes 45 degrees angle with vertical. Here weight of the rope is acting in downward direction, mg in this direction is equal to 10 into 10, that is equal to 100 Newton. We have to find the F value. Let T be the tension in the rope up to this midpoint and the suspended point. Then tension resolves into two components. Vertical component of tension is equal to T cos 45 and component of tension along horizontal direction is T sin 45. And this point is in equilibrium. Now we apply translational equilibrium condition to find F value. Along horizontal, translational equilibrium condition is positive x direction force is F, that should be equal to negative x direction force T sin 45. Similarly, consider translational equilibrium condition along vertical direction. Along vertical direction, downward force is mg. It should be equal to upward force, vertical upward force T cos 45. Take ratio F by mg is equal to T get cancelled, that is tan 45. Then F is equal to mg tan 45. So that is equal to mg into 1. mg is 100 Newton. So F is equal to 100 Newton. So answer is A. Students, consider the second problem of 2020 JEE Main January problems in Newton's laws of motion. A uniformly thick wheel of moment of inertia I and radius r is free to rotate about its center of mass. A massless string is wrapped over its rim and two blocks of masses m1 m2 such that m1 greater than m2 are attached to the ends of a string. The system is released from rest. The angular speed of the wheel when m1 descends by a distance h is. Diagram is given in the problem itself. Suppose m1 m2 are like this such that m1 greater than m2. When m1, let initial position of m1 is a. Then when m1 falls by distance h, it comes to position b. If suppose initial position of m2 is c and it rises to a same height h to reach another point d. Here this is h value. As m1 descends by h, m2 rises by h. When m1 falls by h, velocity gained by m1 is v. At the same time, velocity gained by m2 is also equal to v. They are moving with velocity v when they travels through distance h. Velocity should be same because they are connected by same string. Velocity is also same at same instant of time. Let v be the velocity of each body. And at the same time, the pulley is at that instant pulley is rotating with angular velocity omega. R is the radius of the pulley, I is the moment of inertia of the pulley. Then the tangential velocity of the pulley is equal to v. V is the velocity of the string, velocity of the two blocks at a particular instant. Therefore, the v should be equal to r omega at the instant when mass falls through h. Then we have to find the angular velocity. In this problem, the question is, what is the angular speed of the wheel when m1 descends through h? So to find that value, the best method is use law of conservation of energy. So we solve this problem in different methods, but here we are using law of conservation of energy to find omega value. Here loss of potential energy of A. Loss of potential energy of A means m1gh is equal to gain in energies. First, gain in potential energy of B, that is m2gh. Gain in potential energy of second body, m2gh, plus gain in kinetic energy of A, so half m1v square, plus gain in kinetic energy of second body, half m2v square, plus gain in rotational kinetic energy of the wheel of the disc. So gain in rotational kinetic energy of the wheel, rotational kinetic energy formula half I omega square. So once again, this is the important statement. Loss of potential energy of the m1 is m1gh should be equal to gain in these four energies. Gain in potential energy of second body, m2gh. Gain in kinetic energy of the two blocks, half m1v square plus half m2v square, plus gain in rotational kinetic energy of the wheel, rotating wheel. So that we take this m2gh to the LHS. So m1 minus m2 into gh is equal to, here half v square common. So half into m1 plus m2 into v square plus half I omega square. Here omega is the required value, v square should be changed in terms of omega. So m1 minus m2 into gh is equal to half into m1 plus m2 into v square. Already we discussed that v is equal to r omega, v square means r square omega square plus half I omega square. 1 by 2 common from these two terms, and on cross multiplying we get 2 into m1 minus m2 into gh is equal to, in the remaining two terms take omega square common, omega square into m1 plus m2 into r square plus I. Now omega square value, omega square is equal to 2 into m1 minus m2 into gh divided by m1 plus m2 into r square plus I. Take r square common to get the answer. Take r square common in denominator. So 2 into m1 minus m2 into gh by r square common into m1 plus m2 plus I by r square. This is the omega square value. Now omega becomes, by taking square root on both sides, here 1 by r square root of remaining value is 2 into m1 minus m2 into gh by m1 plus m2 plus I by r square. So answer is A.